All right, we're going to be digitizing maps for our lab on Thursday, but some of you have already played with this in Lab C. If you brought in an aerial image that did not have any orthorectification, I showed you how to geolocate that image using the tools in ArcGIS. That used to be a lengthy and painful process, but the newer GIS systems have made it as simple as clicking on a dot on your image and a dot on a map, which is pretty revolutionary. You no longer have to have a lot of background knowledge of the computations that are being performed for that. But the more that you do learn, the more you can learn about the settings that you can control. ArcGIS has a whole library of different transformations that can be performed on a raster image. So understanding how those work is really powerful. We're not going to get deep into that. What we're going to be looking at is digitizing vector objects. So we will be taking raster images and making vector information out of them. So this is essentially what I've been spooling you guys up for all the way from the beginning. We're taking the real world, except it's the real world that's already interpreted into a raster image, so it's lost some detail, it's lost some information along the way. But we're taking what is a large amount of information stored in a raster image, and we'll be turning that into vector data, which in its nature carries far less information. So back to the old theme of real world into objects. Sadly or happily, depending on your perception of the paper world, we no longer do hard copy digitizing, but it is always an option. I actually had on an assignment earlier this summer, all I had was a paper copy of a plat that had useful information. I was able to take an image of that with my iPhone in the field, throw it into my mapping software, which is QGIS typically at work, and georeference that snapshot that I'd taken. So far beyond leaps and bounds ahead of what happened when drafters actually had drafting tables, which you can pick them up at garage sales all over the place now. They're not as useful as they once were. But cool still. Now we perform on-screen digitizing with images that have gone through some amount of processing. Most aerial photos are taken from a airplane. Some of them are taken by satellites, but most of the ones that we use for detailed digitizing of feature information are taken from airplanes. So they're taken at different altitudes and different angles. And a lot of that can be corrected before it's brought into your GIS software or as it's being brought into your GIS software. And then we take that aerial image and we start to pick out the features that we're interested in. And there are tools built into ArcGIS for doing that. So as you're creating these vector interpretations of the real world, there are some important rules to follow. We talked about topology in an earlier lecture, and topology is what helps keep your interpretations of the real world systematic. So it sets a baseline of rules. Your lines will always intersect at a node. You're not going to have anything that crosses over. You're not going to have points that don't snap to places. So you can see on the left of this slide all of these little not quite connected elements, and you might not even be able to visualize these in your software. If you're zoomed out to the point where you can't see that each of these nodes are connected, they might look like they're laying on top of each other. But if you haven't enabled what's called snapping in your software, there's a very high likelihood that they're not actually occupying the same infinitesimal point in GIS space, right? Your computer is going to give you the ability to define a position well beyond what you could ever actually survey. So you could lay 2 points within millimeters, or I don't even know how to get small enough, micrometer points of each other, which isn't real in a mapping system. So those points should be connected, because then they can behave in the same way. And that becomes really important when you start running computations on areas, so you don't have overlapping features or features with gaps between them, and for a lot of other purposes for data analysis. So this is the mapping stage of making sure your topology rules are being followed. So this is a set of digitization errors that can be avoided by using snapping. And this is just a little inset here showing the snapping tools available to you within ArcGIS. And if you were able to mouse over each of those, they would explain what's being accomplished there. Some of them are snapping at vertices or nodes. Some of them are snapping at intersections. Some of them will snap to any point along a line, just to make sure that you're snapping to that line and not somewhere else, which, as we mentioned, kind of violates one of the topology rules, which is intersecting lines cross at a node. But you have a lot of tools available to you as you're building your GIS database to utilize snapping. And then you have some protocols that you can run after you're done to check your topology and make sure that it's all following the rules, which is one case I advocate following the rules, because it will serve to simplify your life. So this is that process of georeferencing. Right, when you look at it on the face of it, and you're just taking an image and you're picking out points in that image and you're finding them in your map somewhere, and using that to place your image in the right place, it doesn't look like there's a lot of work being done in the background, right? You're just taking this sort of elastic image and stretching it out all over the place, right? But that's not the reality of things, right? The definition of a raster is a gridded area to which each grid element, each cube, each square within your raster is assigned an attribute. So when you've taken that raster and distorted it, you may be doing stretching, and that stretching might be different in two different directions. But your output raster is still going to be gridded, and most likely it's going to be a gridded square. We don't tend to do this with like tin type objects. We tend to do it with a square grid. And so we have to resample our data in such a way that the output raster still represents the same information as the input raster. So that might mean taking very large squares and dividing them up into multiple squares, or combining squares, or defining our transformation in such a way where we say, well, this used to be the center of a square, but now it's the corner of a square, and at which point am I going to assign that information to which square? And that's part of the information that happens in the different processing methods that you can control when you're using the ArcGIS referencing tool. We didn't get into that before, but there's a couple examples on here. Using nearest neighbor input, using bilinear interpretation, or cubic, I can't talk today, cubic convolution interpretation. There's a lot of different polynomial type and georeferencing tools, and they all require a different number of points of input. So you can digitize a raster with just 3 or 4 points, or you can digitize a raster with 12 anchoring points, and that 12 anchoring points is going to give a lot more information into your model about how that raster is being adjusted than just telling it where 3 or 4 points align. So luckily Esri does most of that work for you. You just need to understand if you've selected a different transformation model for whatever reason. Sometimes it depends on how your image has been distorted. You can see that sometimes in the image. So your selection of your georeferencing model might try to compensate for some of that, and the number of input points might therefore have to change to go along with that. It's also a really common practice in the acquisition of aerial imagery data to have specified survey points on the ground that are used in this process. So surveyors will go out and they'll lay out, say, a 6-foot X on the ground, and they'll precisely locate the center of that X with survey methods, and then provide that information to the people interpreting the aerial imagery so that they can use that to perform these transformations. So that's a really concrete example of how this is used in the real world. And then you get to reproduce that digitally. Somehow made a blank slide. Oh no, we reached the end. We did it. Sorry, I thought there were a few more to go. We ended here because this is something we'll be talking about more after the midterm. So your lab next week will not involve georeferencing. I will hopefully have the energy to georeference a couple of alternative images for you over the next couple of days. If I am not able to attend lab on Thursday, we have two options. I can get somebody to, all right, does anybody have any questions about map making? Are you guys excited to make maps? It's my favorite thing to do.
Super, super excited.
Yeah, sounds pretty exciting.
It should. All right. Any questions about non-lecture related? Any questions about previous assignments? My email to you guys the other day, I've lost track of how many days that was. I noticed a stream of assignments coming in now that I have the app on my phone, which might be a mistake. Did you guys know that Blackboard has an app with tools for you? You probably all did.
No, I don't.
Yeah, I didn't know that either. Would it be helpful for me to have that, or?
So far, for the extent that I'm using Blackboard, it would tell you, I think you get a notification when there's a grade posted. I get a notification if somebody makes a wiki post, I think. That's why they're coming in. I don't really know. There's two different apps. There's a student app and a teacher app, and I get notifications on both. And so far, I haven't been able to pay attention to them. So that is available. Oh, I believe it also, you would get the messages that I've been forwarding to email. Not all, that's an option when I post those messages. So it might be helpful for checking back on announcements in your various classes.
Brenda, I have a question about the lab and also a general question looking at the wiki page.
A question about the last lab?
Yes, which I missed.
Okay.
So I think it kind of follows that instructions in Paul's book. So I think I've essentially did already most of it when I was following it by myself. I have two questions. First, what do you imply when you have this question? What's wrong with the lab? Like which direction I should be thinking?
That's my question to you. No, we did go over that a little bit at the end of the lab. So basically, the problem that I have with this lab is what he's trying to show you is that by reprojecting your data into the correct projection and bringing it into the map, you can match your projection. However, the way he's having you demonstrate that is by using the measuring tools within ArcGIS. So it's really important to remember your map has a projection and your data has a projection. When you use the measuring tools in ArcGIS, it's always going to report to you on the map projection. So if you're measuring a line or you're measuring an area, that's going to report in the map projection. If you are calculating a field in your attribute table using the tools in your toolbox and appending them to your shapefile, that's going to use a projection of your shapefile, and those are two totally independent things. They could be the same or they could be different. So I feel like there's a flaw in this lab. If he had you calculate areas for these different shapefiles, he would have actually demonstrated to you that they are in different projections and they are projected correctly within the map. But by just measuring from point to point, all you've demonstrated is that your map is in the projection you think it is. So I think he kind of missed the bill there. He had you export to another projection, but didn't highlight the difference between those tools. Does that make sense? I haven't really mastered expressing that yet, and I feel like that's part of the challenge with the lab, is that it's not necessarily something easy to make clear. But that doesn't change the assignment. If you followed the instructions in the lab, that's exactly what I expect to see from you. I gave you the Google form to try to make it easy for consistent input.
Yes, and that's the second question. I tried putting things into the Google form, and if you just scroll up just slightly on your page, here you have the spreadsheet with area and this second row of east, west, and north, south something meters. There's no way to enter this into the Google form. Because my Google form, when I tried to answer the questions, it was give me the coordinates, give me the distances, and then what's wrong with the lab, done.
I suppose I should use my real.
So you can type in, yeah, you can
for distance.
Yeah, you can type in whatever.
Yeah.
You type, next. Again, coordinates, you type.
Yeah.
It's all good. Say next. And then what's wrong, and it doesn't ask you anything else. So it doesn't.
Oh, sorry. If you calculated area, then you went the extra mile. I'm sorry, that was part of my experimentation to try to demonstrate to you guys the failure on the back end. So ignore the area for now.
I mean, I totally don't mind doing it because it's kind of good to practice, but I was wondering how you can, okay.
Yeah, so my question to you is, did you use the area measurement tool?
I didn't yet because my second question is, you're looking for the area of a county, or you're looking for the area of the entire Minnesota? What area are you looking for?
So I think I measured the area of the county he had you take a coordinate from.
Right, okay. Okay, and so the second row you have, which is with the columns east, west, and north, south. What are those?
Those are your eastings and northings
for
your coordinates.
Okay, so that's the one you're asking.
That's your XY.
Okay. All right, got it.
Yeah. I didn't want to lead you into the decision of whether or not they were eastings or westings.
Okay.
But in the US, they're going to be eastings and northings.
Right. Okay.
99% of the time.
Okay.
Sorry for that confusion. It made more sense in the context of the brief discussion we had last week.
Right. And last question. So if I'm looking at my wiki page, I see everything very small and occupying like about a third of the screen. And I only see everything big if I edit it. So if I want to make comments on somebody else's wiki, it would be nice to actually see the map rather than see the totally shrunk piece. What's the best way of viewing somebody else's wiki pages?
So the best way is to encourage your fellow students to change those settings when they put them in. Unfortunately, there's not a lot of tools that we have control over in a wiki. I've been underwhelmed by that tool. I don't think I'll use that quite the same way next time. But I think I showed you guys, were you here when I showed you how to change the size of your images?
Probably I was, but I don't remember how to do it.
So you can do that when you input them. So each of my maps I have, or each of the images actually in my wiki.
Well, Brenda, you just illustrated my point. So if when you're editing it, they look really big and really nice. But before you click the edit wiki, it was all shrunk and super hard to see.
Yeah, so you control how much shrinkage you have in here. So when you go into your appearance, you constrain your proportions.
Okay.
So this image should never get less than 1800 pixels. It doesn't help that I have my Google scaled right now to 75%, but if we looked at this at 100%, that is the reason that my images are consistent width. It clearly could have gone wider, but it's going to depend on your screen proportions, but they're at least consistent. And that's going to vary depending on how everybody uploaded. Some people have been attaching files, which works okay. It's a little slower for me to grade that way, but I'm not too broken up about it.
What's the alternative, like inserting an image?
Yeah, so using the image tool to insert your image.
Yeah, I think that's how I've been doing it.
So it's the difference between attaching and inserting.
Okay.
But it's not, it's not what we're here to learn, and I'm not too hung up about it. It is a little more convenient to have the image embedded.
And I've been doing like the custom 6" by 6" thing, like consistently throughout the whole thing. Does that even matter, really?
For the images?
Yeah.
I think it does make it a little easier to go through. For the size when you make your map, you mean?
Yeah.
So we talked a little bit about that in some of the earlier labs. The size of your output is going to just vary depending on the purpose of your image. So that's somewhat in your own little fantasy world of what am I going to do with this map? Is this a map I'm going to carry around with me when I'm backpacking? Then 8.5 by 11 or whatever the largest size your printer can print would be awesome. If it's a map I'm going to inset into a report, I have a pretty standard 6 by 6 or 4 by 6. Just makes it clean and easy to deal with.
Sure.
So whatever your fantasy world tells you to do.
Sounds good.
Unless there are
no,
instructions.
it doesn't really matter.
Unless there are instructions to the contrary.
Sure.
So.
Yeah.